Hello guys, we are back with another Leetcode problem. Today we are going to solve a very interesting problem, and today's problem is permutation. So it's a medium question and it's a highly like. So it must to do question. So you let's dive into the question. You have given an array nums in which possess distinct integers. You have to return all the possible permutation. You can return the answer in any order. Okay, you have to return all the possible permutation. So let's understand this question with using the example one. So you have given an array and you have to find out the all the permutation we can form by using this 1 2 3. So the possible permutation will be 1 2 3 itself, 1 3 2, 2 1 3, 2 3 1, 3 1 2 and 3 2 1. This is the all possible permutation, and you can't make another possible permutation instead of this. So these are the possible permutations of 1 2 3. So we have to what we have to do, we have to return the all possible permutation. It can be in any order, so order is not matter in that time. So how, let's see this for this example 2 for little bit more clearance. So 0 1, and the all permutation of 0 1, it's 0 1 itself or 1 0. That's only two permutation you can mix by using 0 1, and that's it. For the one, you have only one permutation is available. So how can we generate all the permutation possible permutation? So let's dive into the code and let me explain everything. So what I need to do, and actually what is on my mind. If I want to generate 1 2 3 string, so what can I do? If I swap two values, let's say this one to this two, and this is my one answer. If I swap this one with 3, so it will be my another answer. If I swap this 2 with 3, it may be our next possible answer. So what actually does, I swap the values and just print this, store this into the my any vector in which in the answer vector. That's my main intuition. But how can I do? If I try to do it manually, it it's a more lengthy to doing that. So here I'm going to take help of recursion. Recursion do its own work. I'll just handle these some cases and recursion do its own job. So just rely with the recursion, and you can say it's a little bit backtrack type. So let's go. So for doing this, what I did, I make a globally variable in which I'm going to store my answer. So it's a int, let's name it result. And if I want to do some work on the recursion, so I'll make a, it's a better to make a function which going to help us. So I make a solve function. I'm going to pass the parameter, but still in the initial stage we just leave that thing, and I'm assuming my solve function store the answer into this result vector, and I have only one duty, I have to return this result. That's it. I have to make this solve function and I'm done with that. So what's actually solve? So solve function actually what it does, it takes some parameter. The necessary parameter is one of these nums in at this point of time, and I have to make a temporary vector which is going to store the data. So I make a temporary vector in which I'm going to store the uh, one of the permutation, and it's initially stage it's empty, and what I need to do, uh, yeah, I need a start pointer because when I just going to return, let's make my one of the pointer. I'm just traverse. I'll just make this swap these two values. So I didn't return here because it's make little bit confusing. If I traverse, what I do actually, I'm just traversing from here to here, and which I want to swap it, I'll just swap it. And if I reach to the end, I'll just return it from here and store that number into my resultant vector. So that's my approach. So that's why I'll just make it a start pointer in which it consists is starter and another is last int nums dot size minus, not a minus one. That's it. So let's complete our stub function. It's a void type because it can't it not doesn't return anything. So void type, and it's a vector, sorry, int uh what is name, nums. Another parameter is another, it's also a vector, it's a temp. Another one, it's starting pointer, let's name it L. Another is right pointer. Whenever if I reach my L is reaching to the R, that's my base case. I have to return it from here. But before returning it, I have to push this temp may be modified. So I have to return this temp. But it's a lengthy process because I can do with my nums too. So why I'm using temp here? So I'll just delete this temp. I guess I can do without using the temp. Temp is a one of the option. I can update it on that and then return it. But it's consuming. Why we just why we use this space? If I without using space we can do. So here when L is equal to R, what I do, I'm actually I'll just store my resultant into. I'm going to change this into my nums, not in a temporary variable. Whenever I made a change, I'm going to change into this num, not anywhere else. That's my motto in that. So I have to return this whenever my L is hitting to the R. I'll just return the my nums from here and return it here. But if not the case, that's my base case actually. Now the thing is that I have to do some manually thing. So what I want to do manually, uh, yeah, num dot size. Actually my pointer is starting from this L. This L actually indicate the starting index. Now initially my starting index is 0, and let's remove this temp too. Okay, so it's indicating the starting. So I want to swap this thing with any other element, other element. So what I need to do, I have what I do, I'm actually swap this L to the any of them. I'll just swap it this one by this one, this two, this three. So what I actually do, I'm just going to with the backtrack. First and foremost, I'm do something. After that, I'll do my manipulation. After this, I undo the process. In the backtrack, there is a three steps in the backtracking. First step will be I make some, I'll visit this thing or maybe make some changes. Another, I do my action. What action I have to perform, I'll do that. And after that, what I make the changes, I have to remove these changes again. So undo process. So this is the three cases I have to handle for the backtrack. So I'll just make I'm going to make my first step do function. So what I actually do, I want to swap with this to another variable. So how can I do? I have I want to swap this L, means L is a fixed position. I'm only swap the starting to the any of them. I'm start first and foremost. I'm swapping this first starting element to the starting element because I also point in the starting element. Again, I'm swapping this L to this next element of L and so on. So that's my motto. What I do, I make the I'll just swap it. That's my do function is completed. Now the I have to perform the action. So performing so I have to performing the action. For performing action, what I do, my nums is going to be nums. After that, I have to I have if I swap this thing, I have to enhance my L plus one, means I have to I do for this. Let's say I'll do for that element. So I'm going to doing something for this, and after that I'm going to doing for something this for this. So that's the thing I have to do. And after doing that, and I have to return, means that's my completed this function. And I'll complete it with do and action function. Now I have to undo the process. If I swap this L to I, so if I again swap it, it's normal. If I made the changes, if I again swap it, it's a normal. So I'm for undoing process, what I do, I'm again swap this L and nums I. So it's undo process done, and that's it guys. That's my code, and let's run this code. Yeah, that's accepted. Let's submit our code guys, and that's accepted. So it's a simply a backtrack question, and it's a basic of backtrack. For doing the backtrack, you have to make some do process, we have to make some changes, and after completing our action we have to undo the changes. So that's a motto. So if you have any doubt, let me know in the comment section. I resolve your doubt as soon as possible, and until then keep grinding guys.